This is AP Calculus 8-1, average value. And I'm skipping around a bit. I'm putting this in with chapter 6 things. It just makes more sense to me to cover average value while we're still doing integration, because this isn't, it's an application of integration. And average value, I've also heard it called average rate when you're dealing with application problems. It's the idea that if we have a function f of x and we've drawn that function and we know that the integral from a to b is the area under that curve of f of x, which is something we've been studying in chapter 6. The idea is that if you draw a rectangle, and this goes along sort of with Riemann sums, if you draw a rectangle using the a and b interval as your endpoints, there is some place where the height of that rectangle that you draw, if you find the average, or if you find the area of that rectangle, then the area of this rectangle will be equal to the area under the actual function. And the idea is that this portion of the f of x function that's not included in the rectangle is equal to this portion that is included in the rectangle, giving you the average value that is very, very close to what the actual area under the curve would be. And in order to do that, they would give us the a and b values, and they will give us the function. And then to find the average value, or to estimate the area under the entire curve using average value, we would use the formula 1 over b minus a times the integral a to b of f of x dx. And you find the integration just like normal. You plug in your a and b, get this area, and then you will multiply it by 1 over b minus a to get your average value. If the directions tell you to find the average value, they will always give you a function, and then they will give you an interval that we're talking about for that function. This interval gives you your a and b value. So we know that if it's asking us to find the average value, we're going to use the average value formula here. And the f of x function is tangent, and we're going to plug into this formula, find the integral to get the answer. So if I set this one up, I'm going to have 1 over b minus a. b is pi over 4, a is 0. So pi over 4 minus 0 is pi over 4. Then we're going to multiply that by the integral from 0 to pi over 4 of tangent x. And it is an integration, so we do need the dx. So if I just simplify this a little bit, that would be 4 over pi. If I take the integral, well, the integral of tangent, remember that's sine over cosine, and that is a natural log situation. Remember in one of the last sections we learned that the integral of tangent is negative natural log of the absolute value of cosine x. And that is going from 0 to pi over 4. So I'm going to bring the negative out, and then I'm going to plug my a and b in to figure out what this is. So I've got, if I plug pi over 4 in, I've got natural log cosine of pi over 4 minus natural log cosine of 0. I'm going to draw a little unit circle, and I'm talking about pi over 4, which is 45 degrees. We know that at 45 degrees, our x and y coordinates are both square root of 2 over 2. So if I'm talking about cosine at pi over 4, that would be square root of 2 over 2. So I have negative 4 over pi times natural log of square root of 2 over 2 minus natural log cosine at 0. We know this ordered pair is 1, 0, so cosine would be 1. So that's natural log of 1. Well, we know that the natural log of 1 is 0, hopefully. If you don't, you can put it in your calculator. That is something I would memorize. That's one of those things that shows up a lot on the sample AP test that I've given, because they're going to expect you to know that the natural log of 1 is 0. So if you know that that's 0 and it's a non-calculator problem and you've memorized it, then you don't have to worry about that. But if you can't remember what that is and you don't have access to a calculator, that might worry you a little bit. So natural log of 1 is 0. And so if that's natural log of square root of 2 over 2 minus natural log of 1, then our answer is just going to be negative 4 over pi times natural log of square root of 2 over 2. If it's a non-calculator active problem, you could leave it negative 4 over pi times natural log of square root of 2 over 2. If it's calculator active, they're probably going to want the 0.441. The next one's a little bit easier because it's not a trig function. I think the trig functions are always a little bit harder because you have to memorize so much with those. If I set this up using my formula, 1 over b minus a would be 1/3. I have the integral of x squared plus 2 dx going from 0 to 3. If I integrate that, I've got 1/3 x cubed over 3 plus 2x going from 0 to 3. When I plug in the 3, I've got 27 over 3, which is 9, plus 2 times 3 is 6, minus what I get when I plug 0 in. Well, that'll be 0 plus 0, which is 0. 9 plus 6 is 15, and 15 times 1/3 would be 5. Here we've got the same directions. Find the average value of each of these functions. Go ahead and pause the video, see if you can get these on your own, and then I'll give you the answer shortly. So here are your answers. To set this one up, 1 over b minus a would be 1/2. The integral from 0 to 2 of the original function. We tag a dx there. I used u substitution here. My u was x cubed plus 1. The du then would be 3x squared dx. Knowing that this needs a 3, I put a 3 in front here and then tag the 1/3 on the outside so I didn't change its value. So that makes the outside term 1/6. And then I did du substitution. So that's u to the 1/2 times du. When I integrate, I get u to the 3/2 times 2/3, which makes that new number in front 1/9. And when I resubstitute, I get x cubed plus 1 to the 3/2 going from 0 to 2. I plug 2 in. When I plug in 2, I get a 9 to the 3/2 power. Well, 9 to the 3/2 means the square root of 9 cubed. Square root of 9 is 3, 3 cubed is 27, and 27 times 9 is 3. Then I plug in 0, getting a 1. 1 to the 3/2 is 1. 1 times 1/9 is 1/9. So we have 3 minus 1/9, which is 26/9. In the next one, my function, I put behind the integral, going from 0 to 2, and then the number in front is 1 over b minus a. b is 2, a is 0, so that's 1/2. I integrate. First I separated, and then I integrated. So the integration of 8x is 4x squared. Integration of 3 is 3x. Integration of e to the x is e to the x, so we have 4 times e to the x. That 1/2 is still on the outside, and that goes from 0 to 2. When I plug the 2 in, I get 16 minus 6 plus 4e squared. When I plug 0 in, I get 0 minus 0 plus 4 times e to the 0, which is 1, so that's just 4. So I'm going to add, all of these like terms together. So 16 minus 6 is 10, minus 4 is 6, plus the 4e squared, and then I multiply everything by 1/2, giving me 3 plus 2e squared.